Welcome to today's video for section 1.2, functions and their graphs. Today, the first thing we'll talk about is what is a relation, and a relation is basically a set of ordered pairs. For example, if you just had a set of ordered pairs like 0, 1, 1, 3, 2, 4, 3, 6, that is a relation, just a group of ordered pairs. The domain of any relation is this, or another way to refer to the domain is the inputs. It is basically the set of first components, whether they be x values or whether they be inputs, the set of first components in a relation. And a lot of times we refer to them as the x values. The range, which we refer to a lot of times as the set of y values or outputs, is basically the set of second components. In a relation. So if it asks you to find the domain and range of the relation, basically you want to look at, okay, for the domain, what are the set of the first components? And you have 0, 10, 20, 30, and 36. That is the domain. The range is the set of second components. So you have 9.1, 6.7, 10.7, 13.2, and 17.4. A function. Well, what is a function? A function basically means for every input in the domain, there is exactly one output in the range. So for example, if I want to determine whether any of these relations are functions, one of the easiest ways to do it is to make a diagram. So if I want to say, okay, this is the domain of this, is you have 1, 3, 5. That's the domain for part A. For the range, 1, it's 2, 4, 6, and 8. And if you notice, 1 goes to 2, 3 goes to 4, 5 goes to 6, and 5 goes to 8. So if you notice, in this case here, for every output, or for every input, sorry, there is not only one output. The number 5 has 2 outputs. 5 has 2 outputs. So basically, this would not be a function here, because 5 has 2 outputs. It has 6 and it has 8. Notice for the second one, if we do the same diagram, here's the domain and here's the range. We have 1, 3, 6, and 8, and then 2, 4, and 5 for the range. But notice 1 goes to 2, 3 goes to 4, 6 goes to 5, and 8 goes to 5. This is a function because if you notice, each domain value only goes to one range value. It's okay if the domain value goes to the same range value as long as it's a separate one. So for example, 6 only goes to 5, 8 only goes to 5. Whereas up here, notice 5, if you look up here, 5 went to 2 separate ranges. That's not allowed. So the next example, it says solve each equation for y and then determine whether the equation defines y as a function of x. Well, if you notice here, we'll solve it for y first. So subtract, and we get y equals negative 2x plus 6. Well, basically here, just pick a point. Like, for example, x equals 0. If I put 0 in for x, I get y equals 6. So notice I put 1 point in for x and I got 1 out for y. This is a function. Let's look at the next one. So I solve it for y by moving the squared over. So I get y squared equals 1 minus x squared. In order to get rid of the y squared, you take the square root. Remember, when you take the square root, you get plus or minus on the right-hand side. So now, if I put 0 in for x, notice now I get y equals plus or minus the square root of 1, so it equals plus or minus 1. That means there's two answers. If I put 0 in for x, I get 1, and if I put 0 in for x, I get negative 1. This is not a function. Function notation. Basically, if you ever see this f of x, it replaces the y to signify that basically what you have there is a function. So if you ever see x comma f of x, those are the coordinates. The f of x just replaces the y. So if you notice when it says to evaluate the function and it says f of x equals x squared minus 2x plus 7, and you have f of negative 5, for part A you just put in the negative 5 everywhere you see an x. So it's negative 5 squared minus 2 times negative 5 plus 7. Negative 5 squared is 25. Negative 2 times negative 5 is 10. Plus 7 gives you 42 when you add that all up. Part B, if I put in x plus 4, so I have x plus 4 squared minus 2 times x plus 4 plus 7. Notice I'm going to have to FOIL, because x plus 4 squared is x plus 4 times x plus 4, and that gives you x squared plus 8x plus 16. Here I have to distribute the negative, so I get negative 2x minus 8 plus 7. So I get x squared plus 6x, and then 16 plus 7 is plus 23. Oh, but then I forgot the 8. So but I gotta go minus 8, so it's actually plus 15. Because notice if I subtract the 8 here. Part C, it says f of negative x. So that means everywhere you see an x, you put a negative x in. So I get negative x squared minus 2 times negative x plus 7. Well, negative x squared is positive x squared. Negative 2 times negative x is plus 2x plus 7. That is your final answer. So here, basically it asks you to graph y equals 2x. So go ahead and do that on your own if you can. So I can make a table. I'll just make a couple points like 0, 0, 1, 2, 2, 4. There is y equals 2x. Now, the vertical line test will basically determine if the graph is a function. Because if a vertical line is drawn and it passes through only one point, then it's a function. So once again, to repeat, if a vertical line passes through the graph at only one point, then the graph is a function. So notice here, this would be a function. Sorry, vertical line test, not horizontal, vertical. Horizontal line, something different. So vertical line test, notice it only passes through at one point when you draw a vertical line. If I did something like this, it still would pass. Notice that would be a function. But if I drew something like this, notice that goes through twice. That's not a function. All right, the next part says use the graph to find the information for f of 1, of negative 1. Well, basically, if I want to find f of negative 1, I come up here and I say, okay, negative 1 is right here. What is f? Well, f is right here, and f of negative 1 is negative 2. So you just look and see, well, if x is negative 1, what is y? Y is negative 2. So f of negative 1 is negative 2. That's how I would read it. If I wanted to find like f of 2, well, 2 is right here, and you go up, and it's 4. So f of 2 is 4. That's how you would answer those questions if you're just looking at a graph. All right, the next thing we're going to do here is draw a graph. So we'll do, here's negative 2, here's 5, and let's draw there. Let's go up to 5, and we'll put a point at 2. We'll put a point up here. This is actually 4. So we'll go like this. There's our graph. Now it says use the graph to determine the domain and range of the function. Well, domain, remember, is the x values. So I'm looking side to side. Well, I notice it starts at negative 2 and it ends at 4, right? That's the horizontal part of the graph. So to represent that it starts at negative 2 and ends at 5, I'm just going to put negative 2 comma 5. And remember the interval notation. If it includes negative 2, I put a bracket. And if it includes 5, I put a bracket. Notice both circles are filled in, so it includes those two numbers. Next, the range. Well, range, remember, is the up and down part. Well, the bottom part of the graph is 0 for y. The highest point on the graph is 5, and it includes both of those, so I'm going to put 0, 5. Something to keep in mind also about domain and range is anytime that you have arrows in both directions, that means the domain would be all real numbers. And to represent all real numbers in interval notation, we go negative infinity to positive infinity. If I have arrows in both directions like this, it may not mean that the range is all real numbers, it just may mean the domain. But anytime you have arrows on both sides like that, it means the domain is all real numbers, and we represent it from negative infinity to positive infinity. We'll talk more about this in class as we do some problems, but hopefully you have a good weekend, and we'll definitely work on some of this in class. All right, have a good weekend.